Hello guys, if you're a front-end engineer or a JavaScript professional, you have seen this question somewhere in your life. This is a tricky question, but if you know how the heck event loop works, then you can easily solve this in your fingertips. As we know, JavaScript is a single-threaded programming language, and all the synchronous code in your file going to run in a single pass. But if there is any asynchronous code, it's going to just put it somewhere to run it later. This. And if you see, this file has asynchronous and as well as synchronous code. This is synchronous code. This is synchronous code. And this all things you see are basically asynchronous code. Which one is going to execute first? I want you to keep 10 seconds. Think of your answer. Put it on a comment. Then after 10 seconds, I'm going to start with the actual logic and how you can solve this error. You might be having some answers by now. But now let's actually understand how this logic works and how JavaScript works behind the scenes using event loop and how this program is going to execute. Cool. So whenever you are going to run this program or program similar to this, what's going to happen? The JavaScript is going to run line by line. That is a basic functionality of JavaScript. It runs line by line. So first it's going to run this line, console.log start. Console.log start is a synchronous function in JavaScript, which is going to execute immediately whenever your JavaScript engine going to see it in the program. So what's going to happen? This program is going to go in call stack. So call stack is a stack, like stack is a data structure, which keeps active functions execution context, or just keep the stack of all the active functions. So whenever JavaScript sees this, it's immediately going to pass this console.log function in this call stack with this value start, and it immediately going to execute it. So as far the output is going to be, the first we are going to immediately see start. Because there is synchronous code immediately executes. All right. Now, it's going to go to the second line, set timeout. So in your JavaScript engine, you don't have only call stack, you have something called web API stack as well. So see, JavaScript is a core programming language, which is meant to be used in web. But core JavaScript doesn't have all the functionality what web gives you in now modern web development. There are a lot of web APIs you use day by day. For example, DOM manipulation, where you just change in DOM, maybe using inner HTML or using React shadow DOMs. Fetch networking, you use fetch and you just get something from the API calls. You use local storage, you use timing functions like set timeout, we have here, set interval. These are the functionality which is given on top of JavaScript as an extended functionality by JavaScript engines on web. Like Google uses V8. V8 gives you this functionality, not the core JavaScript. All right. So apart from call stack, there is web API stack as well. So whenever there is anything which is coming from the web API extendability of JavaScript, it's just going to put the context of a function or a callback inside the web API stack, not the call stack. Now this callback is going to go, let me change the color, which will be much better to understand. And let's use this. This is going to go web API stack. And now this callback is a set timeout and it is in web API stack. This callback is going to go to the macro task, the macro star. The macro task has now this console.log 1 right here. It has one task now. Sorry, it is in the macro task, not the micro task. So whenever you pass callback to maybe event handlers, to set timeout timing functions, to any local storage, all those callbacks are going to be stored in macro task. And macro task is just a callback queue which going to keeps a record of all your callbacks coming from web API stack, and it's just going to execute them later whenever your file completes execution. See, whenever you have wall file executing, the asynchronous code is not going to execute at the same time. It's just going to wait for the wall file to execute first, then only is going to execute the asynchronous code. Still, I have the file still right here in this position, like here. It is not executed fully. It's just here. So right now it's not going to execute. This function is just going to pass it to the macro task. Now the question is, what is macro task? As a definition, it just keep async callback function. Whatever async callback function you do have, it's going to keep them there. Cool. Web API stack, receive this, set timeout as a callback. Callback is going to pass to macro task. Simple. Now the next line is that there is no output yet. It's just it goes to the next line, which is also asynchronous code. Now let's again change the color and let's see how it works. Okay, promise or resolve. Promise is a asynchronous logic where you are passing resolve. Resolve means it is going to resolve whatever resolve executing you have passed. And we pass then. Whenever we pass then, it again is going to return me a promise. Then catch finally returns you the promise. So this then again going to be called in call stack. It is not the part of web API stack. It's a part of your core JavaScript programming language, right? It's going to go to the call stack, and call stack going to have this callback console.log2, and this going to stored in micro task. Okay, micro task is very much similar to macro task queue. It's just going to keep async promise functions, async promises callback functions rather than the callback function coming from the web API stack. Like this. This is the callback coming from the promise API. But there is a difference between these two, micro task and macro task. There is a difference of priority. Whenever you see micro task or macro, so micro task queue has the more priority than macro task. Whenever your event loop sees, okay, so there is a two function which I'm going to execute first. So or event call is always going to pick the task from the micro task, not from the macro task. Okay, now we have another function, this, and it is stored in micro task, and it is again not executed yet. It's going to wait for the file to be executed properly. Again, we do have another promise. But now in this promise, we are passing another set timeout. This is interesting. Okay, so as we know, this promise resolved, then it's going to return you another promise with a callback. It's going to go there in the call stack. But this callback itself is returning you set timeout. But what's going to happen? It's going to be passed into micro task queue. And when the task comes, when the time comes, it get executed, then it will return you set timeout. The set timeout again going to go to the web stack API, and it's going to be passed to macro task. Something like this. Okay. This, and it's going to come here. So this one is going to be executed in macro task, not in the micro task. Cool. Now, this set timeout. Okay, so in this set timeout, we pass the time 0. Here we are not passing time. If you are not passing time, it is assumed as 0. So again, in this case as well, it's gonna go to the can we pick another color? Yes, we can. Maybe let's try this. In this, it's gonna go to web stack and I'm gonna put it to micro task. Cool. And now the interesting one. It is this. Let's go with orange. Yes, this. New promise, and we are passing an executor function console.log6. Now this is funny. Your promise is, the promise constructor is a synchronous code itself. It is not an asynchronous code. Then catch finally are the asynchronous code. This promise is not asynchronous code, it's synchronous code. What's going to happen is going to go there, call stack, and it's going to execute immediately. And it's going to give you the output 6. This is very important to understand. Whenever you're just passing execute a function in the promise, it will immediately execute. It's not going to wait for then and finally, and it is asynchronous code. It's going to print you 6. And now the last part. And oopsie. And this, and purple. This, it's a synchronous code. This goes there, it executes immediately and is going to print you the... It's going to print you the... And whenever you print ends, the execution of your file is done. Now everything is on event loop and the call stack. Now your file is done. Now let's come back to the event loop. Okay, event loop. What is event loop, by the way? Event loop is nothing. It just keep on checking this call stack, web API stack, micro task, macro task queue again and again. This process is called event loop. Event loop has only one purpose. It's just going to see if there is anything present in this call stack, web API stack, macro task, micro task queue. It's just going to execute them whenever their time comes. And this event loop works on ticks. I'm talking about the speed of event loop. See, single thread, JavaScript is a single thread, but it is much faster than you can assume. It works on ticks. Each tick is going to process the whole call stack, web API stack, macro task, micro task queue, and one tick is around millisecond or even nanosecond. It is that faster. And just give me a second. That is like G. Let me know more. Millisecond or nanosecond. That's why JavaScript is a single thread and it is much faster. But the problem with the JavaScript is, if you are having some heavy extensive task, heavy computing task, maybe a task set in macro task or micro task, then it's going to wait there. It's going to stop the event loop and it's just going to wait there. Okay, let the task executes first, then it's going to continue again with the ticks. That is a problem with the JavaScript, but there are many solutions. We are not going to discuss the solution right now in the video, it's just the explanation. Okay, event loop, it just keeps on checking this call stack, web API, macro task, micro task queue, that's it. Now let's actually understand the code. Whenever you see this code, always go with the promises first because micro task has more priority than macro task and micro task always executes first. If you see, this one coming first and this promise is coming second, but this promise has a set timeout and this promise is synchronous, so we don't even care about this now. It is already executed. Apart from these 3 promises, it is already executed. It has set timeout. So set timeout is again going to pass to macro task. It's not going to run any sooner, but this one is going to run. And the next output you're going to get is 2. This is 2. Okay, this is done. We don't have anything left for the promises. Now let's come back to the callbacks. The set timeout of web API callbacks. And we do have this set timeout console.log1. And it has 0 millisecond. We are not specifying any time. If we specify any time, then it's going to wait for that time. But we don't have any time right now. So it's just going to be passed to a macro task at the first position because it ran first. So it's going to execute first. 1. Alright, this is done. Now this set timeout and this set timeout. Alright, so now between these two, this has to travel from call stack to web API stack to macro task, right? And this one is just like, okay, it just went to the web API stack and went to macro task. So this one is going to run first because it has to travel less in this call stacks data structure. And it is going to be 5. And which one is left? The fourth one, because it has to travel a lot. This is the output you're going to get. And this is the beauty of your event loop. If you guys have any questions, any suggestions, please let me know. Please subscribe, please do like so that I can come up tutorials for you. And we all enjoy learning. Thank you so much and have a great day. Let's try dry run it and let's see if we are right or wrong. If I just run it, not hack it, and you will see the answer is almost same like we discussed in the diagrams. Start 6 and 2, 1, 5 and 4. It has to travel 2 callbacks. So it is going to be the last one.